Okay. Hi, welcome everybody. My talk is on inflationary theory from a Vaishnava or classical Indian perspective. So in modern cosmology, it is widely accepted that our universe began in something that is usually referred to as the Big Bang. What exactly that means is the subject of some interpretation, but generally that is included in the model. Historically, the first formulations of the Big Bang left several questions unanswered. For example, the nature of the singularity, the relative flatness of the space-time in the universe, and eventually inflationary theory was proposed to answer the issues with a classical space-time. So a lot of these inflationary theories generally require a quantum cosmology, where instead of operating on a classical space-time, you operate with a quantum model of space-time. And these generally require what can be referred to as a pre-inflationary quantum field. So a quantum field that happens either in the early or pre-universe states that is responsible for the rapid expansion that we see. These underlying quantum fields or related entities share several properties with the Vedantic notion of Brahman. And as such, we can apply arguments from the debates between the Advaita or the impersonalist and the Vaishnava schools to the nature of this quantum field. So just a little bit of a disclaimer. There's a lot of technical things which I'm not going to talk about because if I did, it would take a lot longer than the 20 minutes that I have. So I know there are experts in quantum physics and cosmology and in Vedanta in here. So if you don't see something, it's just because I don't have time to handle it. All right, so just a brief smattering of ideas from quantum mechanics. So in quantum mechanics, rather than a specific state, the system is in a possibly infinite number of states simultaneously in a superposition. So if you see kind of this plot over here, this is for the famous particle in a box. And it's considered to be in a superposition of every position along that line at the same time, according to some probability. And a measurement collapses this superposition into a single value. So then naturally, the next question comes is, what do we mean by measurement? And there isn't really widespread agreement on that. Different philosophers of quantum mechanics have different ideas. But we do know that if you have two quantum systems, so if I have an electron here and an electron here, and bring them together, I get a new quantum system. It's not just, this one times this one or something. They kind of come together and form a completely new system. So to collapse a quantum system, to make a measurement, there has to be some, I guess, interaction or some contact with what one could call a classical system or classicalness. What exactly is meant by classical? Once again, different philosophers of quantum mechanics have different technical definitions for that. The extension of quantum mechanics is quantum field theory. So that was kind of the quantum fields that I was talking about earlier, which is a lot more complicated. It views the main entity as the field, which is a quantum harmonic oscillator at every point. The biggest, I guess, takeaway is the idea of virtual particles. So if we have kind of these interactions, so we see this top one in a more simple example. This is an electron and a positron, which is its antiparticle annihilating. And then we have this kind of internal line of a photon. So that's referred to as a virtual particle. You can also have more complicated things down here, like loops. And these virtual particles are needed for the calculations, but they can have somewhat strange behavior. So for example, they can be what is called off shell, meaning that they don't have to obey certain physical laws. And then of course, cosmology. There are several models in cosmology which incorporate these quantum mechanical ideas into the structure and nature of the genesis of our universe. And they generally rely on, or several theories at least, rely on an underlying quantum field being kind of the substrate by which our universe is manifest. So for example, there's one theory that was at least being talked about several years ago, that our universe is just a virtual particle in some sort of background gravity field or something like that. And of course, other theories focus more on the early universe and posit the inflaton field, which is responsible for pushing everything apart. So quantum mechanics is integral to cosmogony these days. And of course, on the more Vedantic or Indian philosophy side, there is the idea of Brahman, which is considered to be, one could say, kind of the highest reality or undifferentiated potentiality of existence. And the nature of what exactly this is has been debated over thousands of years, with two kind of large schools emerging: the non-dualistic Advaita school and the dualistic Vaishnava school. And both agree on certain things, mainly that the individual consciousness, so all of us individuals here, are unaware of the nature of Brahman. So this is a state called Maya. You also sometimes see the term avidya used, which for ignorance. There are technical differences between Maya and avidya, but for the purposes of the talk today, you can treat them kind of the same. And these two different schools, while they agree on that we're all in Maya, they disagree on basically everything else. So the Advaita school says that, of course, that Brahman is ultimately impersonal. They're sometimes called impersonalists. That it is nirgun, that it lacks qualities, and that ultimately the individual is annihilated after liberation. So that after we get out of Maya, the individual stops existing. The Vaishnava school ultimately says that Brahman is a person, that it is full of qualities, and that the individual is eternal. So even after liberation, there are activities in a liberated state. So the modern conception of these inflationary or pre-inflationary quantum fields have several qualities in common with this idea of Brahman. So we can apply kind of the arguments that have taken place between these Advaita and Vaishnava scholars to examining philosophically this quantum field, either directly or by analogy, because it's not necessarily that we can apply, for example, the shlokas we find in scripture to quantum fields, but we can do it by analogy. So that was kind of the lead up to what the actual talk is about, which is kind of just explaining some of these arguments on both sides. Most of these are due to Ramanujan and his disciples, but kind of just explained or interpreted in new ways. So one question or one argument is that where is Maya actually located? Is it located in the individual, or is it located in Brahman? For the Advaitin, this forms a problem, right? Because how do individuals exist unless there's Maya for them? But how does Maya exist unless there's individuals? Because Brahman is knowledge, it can't be in Maya. So it's this problem of what's called reciprocal dependence. You can't have Maya without the individual to be in Maya, but you can't, in the Advaitin school, have the individual to be in Maya without there being Maya first. Likewise, there's the problem of how what one could call the first classicalness is introduced. So there is again this problem of reciprocal dependence. So remember, when you have two quantum systems and they come together, you form a new quantum system. You don't get a collapse in most models or in everything that we know about. There are some, I guess, theories that you can have that, but in everything that's actually been measured, you just get new quantum systems. So then how is the first classical behavior introduced, and how's this first thing that's possible to make a measurement introduced into a quantum universe? Because you get this same problem of reciprocal dependence. You can't measure a quantum thing to reduce it to a classical state without first having a classical state. Likewise, there's the problem of parts. Traditionally, this is if Brahman has parts, then how are some parts in Maya and others not? If it's supposed to be kind of undifferentiated. Likewise, if the universe is fundamentally quantum, if I have this one big quantum system, then if I make any measurement anywhere, it should collapse every quantum system in the universe. Right, so if I'm in my lab and so I go to UF in the lab and make a measurement of a quantum system, some poor graduate student at Temple University should also have a measurement, should also have the quantum system collapse whether they make a measurement or not, if it's all one big quantum system. Likewise, there's the question of what is actually real. So according to some Advaita accounts, the universe is mithya. It's both real and unreal. And I brought up earlier the idea about virtual particles. And in the philosophy of quantum mechanics, there's the big question, are virtual particles real or unreal? And the Advaitins and the Vaishnavas argue about this and about whether the universe is real or not. And it seems that there's always a problem if you take the impersonalist view or the virtual particles view. One option is that, of course, that it's all just a misapprehension. That there's an underlying reality, and if we were intelligent enough or austere enough, then we would be able to see it. Of course, with virtual particles, the fields are fundamental, so there's nothing behind the fields to do it. Also, so one could just say that it's unreal. Then how can they have real effects, which we measure? Also, if it's unreal, then, or if virtual particles are real, then how come there are certain laws of physics that we can just ignore when we're dealing with them? And of course, you can say that they're both real or unreal, but that doesn't make sense on what we call the law of the excluded middle. So I'm running out of time, so I'm going to go faster. So how do varieties evolve? If we have a reality that has no qualities, or in the case of quantum fields that have qualities that are few in number, mass, charge, spin, etc., then how do qualities arise from a qualityless or small number of qualities substrate? One particular quality is of interest, which is consciousness. Satipatsa Prabhu, Richard Thompson, makes the point in his book Mechanistic and Non-Mechanistic Science that there's no way you can actually show that these mechanistic qualities, mass, charge, spin, give rise to consciousness. And so if this is all there is fundamentally, how do we explain consciousness? So I'm going to go faster because I would like to leave time for at least one question. And then what is the cause? So a general argument or principle is that everything that has a beginning, or that everything that has an end must have a beginning. This is a principle in kind of classical Indian philosophy. So that if a vidya has an end, then it must have a beginning. And then you get basically a cosmological type argument that if it began to exist, it must have a cause. And of course, the Advaitin position doesn't make sense because knowledge can't give rise to ignorance by definition. And particularly with cosmological theories, according to many of these theories, space-time came into existence at the start of these, at the start of the universe. But then how can there be dynamics in a system before there's space-time for it to be defined upon? Because for dynamics, you need some notion of time, things changing from one state to another. But if you don't have a notion of time, how can you have dynamics? So that is just kind of a whirlwind explanation of some things. There is planning to be a monograph forthcoming that will explore these things in more details than a 20-minute talk can do. But I guess hopefully we have time for a few questions at least. Yes, Maharaj.
Very nice, thank you.
Thank you.
I'm wondering, you said knowledge cannot give rise to ignorance. And I'm thinking, isn't it that science is very much about gaining knowledge, which makes one aware of ignorance about more things, which one is then trying to comprehend. So in that sense, can we say knowledge gives rise to ignorance?
We can on the relative platform. So on the specific knowledge that I was talking about here was knowledge of Brahman, which kind of by definition can't give rise to Maya, because Maya is ignorance about the nature of Brahman. Yeah.
Doesn't the Vaishnava school also say that karma has an end but has no beginning?
From my understanding, the kind of individual actions and reactions do have an end in the beginning, but the cycle itself is both past and future eternal. So it depends on whether you're talking about the individual's karma, which I performed some action and then I get a reaction in the future and it's done, or the whole cycle of activity, which as long as the material world is here and was here, it will be here.
There's time for one more question, if anyone wants to.
Like a layperson, how do quantum scientists think about consciousness?
We have 1 minute.
There's a lot of different ways that people think about it. Some, Doug was talking about cosmopsychism or panpsychism. Some people say that it's fundamental. For most of the theories that I've seen, of panpsychist theories that I've heard about, it's more of like an impersonal, consciousness substance rather than like an individual consciousness. Some people say that quantum mechanical aspects in the brain give rise to consciousness. For example, this is like orchestrated OR, for example. And so they do have, there is not kind of one answer that this is what quantum mechanics says about consciousness. There's kind of just different ideas that people have.
Okay, speaker on the panel.